Hey, physical science. This is Wednesday, 4/22, and we're back at it again. We're just going to do some problems today from page 494 to 497. But before we do that, before I erase this board, let me ask if you have your calculator. If you don't, stop this film and go get a calculator. Okay? Now, my question is this. If the average atomic mass for carbon is 12.011, see my neat periodic table up here? Let's take a look at it. Periodic table of the elements. There's carbon right there. And if you look real close next to that 6 up there, you're going to see 12.011. Just like you would if you looked right here. On your periodic table, in the back of your book, 12.011. And the atomic number is 6. The average atomic mass is 12.011. And the mass number of each of the individual carbon atoms, and there's 3 types in nature for carbon: carbon 12, carbon 14, and carbon 13. I call them skinny, fluffy, and medium. The average of all the atoms in the universe of carbon is 12.011. Does that mean that there is an atom that has 11 1,000ths of a particle in the nucleus, 11 1,000ths of a proton, or 11 1,000ths of a neutron? No, there is no such thing. You've either got one or you ain't got one. But the average of all the atoms is that. Now, with that said, do you think that there are more carbon 12s, more carbon 13s, or more carbon 14s in nature? And if you guessed carbon 12, you got it right, because the average is closest to 12. And let's go ahead and see if you got this concept. Let's take a look at the element beryllium. Element number 4. You can see it right there on the periodic table. The average for beryllium is 9.012. But beryllium comes in beryllium 9s and beryllium 10s. It has to have some 10s, possibly some 11s out there. Why? The reason? Because the average is above 9. So there's got to be some heavy ones, some fluffy ones out there that pull that average up a little bit. And if you take a look at that, you'll see that 9.012 is closest to 9. So the beryllium 9, what's the I word? Isotope of beryllium is the most common because the average is closest to 9. 9.012 what? You learned this yesterday. AMU, atomic mass units. Okay, so let's go ahead and do some problems. You got that calculator? We're going to do the one on the top of page 497. Do you see on the second paragraph, page 497, there's a paragraph that says 80%, or 4 out of 5 atoms of boron are boron 11. Now, boron is the element number 5. Let's go find it. The hardest part of doing problems is finding the element on the periodic table. You see it right there, I'm pointing at it. Boron is element number 5, and the average atomic mass is 10.8. But we're going to determine that mathematically because we're going to take the data that we have from experimentation and we're going to come up with that 10.8 all by ourselves. Okay, here we go. Let's go ahead and take 4 out of 5 atoms of boron are boron 11. 80%, 4 out of 5. Do you know how to take 80% and convert it into a decimal? Well, you simply take 80% and you move you bunny hop 2 places to the left and remove the percent sign. It's 0.8. What does 0.8 stand for? 8 over 10. And what is 8 over 10 when you reduce it? Isn't it 4 over 5? If you take a 2 out of here and you take a 2 out of there, you're going to get 4 over 5. Okay, so 4 out of 5 are, what did they say? Boron 11s. So let's write a boron 11. Can I just call it 11? 11, 11, 11. That's 4. And what's the 1 out of 5? They said experimentation showed that 20%, or 1 out of 5, is boron 10. So let's add a 10 there. Let's add them up. 44 and 10 make 54. Now, how many items are there? 1, 2, 3, 4, 5 things. So we're going to divide by 5. So on your calculator, just go ahead and do that. Just put 54. 54 divided by 5 equals 10.8. Or you can do it the old-fashioned way. 5 goes into 5 once. Subtract. Bring down the 4. It doesn't go into 4, so you put a 0 there. Down the 0. 5 goes into 40 8 times. Put the decimal point straight above the decimal. Remember when you used to do that? Does anybody do that anymore? I grew up in high school in the 60s. We did not have calculators. I had never even heard of a slide rule. That's before calculators. So you've valued that value yourself on page 497. So let's go down and take a look at number 10. Page 497, number 10. Chlorine has an average atomic mass of 35.45. The 2 naturally occurring isotopes of chlorine are chlorine that weighs 35 and atoms of chlorine that weigh 37. We got the skinny and we got the fluffy. Okay? And so the average is 35.45 AMU, the average mass number, or the average atomic mass. It's the average, weighted average. And that's chlorine. So I'm pointing at it right here. You see that? Okay, chlorine is element number 17, has an average atomic mass of 35.453. Put that up there. Average atomic mass is 35 point, I'm getting off the table, 35.453. $35.453 what? Atomic mass units. Of course. Okay. And what does it want to know? It wants to know which is more common. Chlorine 35 or chlorine 37? Chlorine that weighs 35 has a mass number of 35. Chlorine that weighs 37. Which one's more common? If you said 35, you're correct. But is that one of the answers? The answer, the question reads goofy. It gives you choices. One choice is, do most chlorine atoms contain 18 neutrons? Or do most chlorine atoms contain 20 neutrons? Well, how many protons does chlorine have? 17. So it wants to know your choices are 18 neutrons. So let's take our 17 protons and 18 neutrons. And so that would be 35 for the mass number. And the other choice they gave us was 20 neutrons. Well, it still has 17 protons by virtue of being chlorine. And if we add 20 neutrons to that, we get a mass number of 37. So don't they kind of have a backward way of asking you which mass number, which isotope of chlorine is more common? Well, you can look at it and see if these are the two choices, it's 35, but they don't ask it that way. They ask, which one is more common? Isotopes that have 18 neutrons or isotopes that have 20? And the answer is isotopes that have 18. Why? Because they add up to 35 when you add it up with the number of protons, and 35 is the most common because it's closest to the average atomic mass. Now let's go ahead on number 9, page 497. This is the last thing we're going to do. Number 9, calculate the number of neutrons in potassium that weighs 40. Calculate the number of neutrons in potassium that weighs 40. Well, why don't we just draw the model? And that'll make it clear to you. What is potassium's number? Well, finding it is the hardest part because potassium has a K. Its symbol is K for potassium, and it's right there. Okay, and so its atomic number is 19. So it has 19 protons. If it weighs 40, what is 40 minus 19? It's 21. So it has 21 neutrons. There is the nucleus. Now, if it has 19 protons, how many electrons does it have? 19, because the positives have to equal the negatives. And I already told you that you can get 2 because it's a small sphere. You can get 2 electrons in that first energy level. You can get 8 in the second energy level. 1, 2, 3, 4, 5, 6, 7, 8. And on the third energy level, you can get 18. And so we're going to go ahead and put 18 in there. Let's see. 2 plus 8 is 10. Another 11 would be 21. Another 11 would be 21. Now, you know what? I'm going to go ahead. Wait, I'm not getting it. It's 19. What's my thinking? It's 19. So you've got 2 on the first, 8 more, that's 10, and 9 more on the third. Except here's the problem. You're going to learn in chemistry, you can only get 8 in here initially. 1, 2, 3, 4, 5, 6, 7, 8 initially. Then you're going to go ahead and you're going to put one out here on the fourth energy level. And that's going to be your 9th one. So you got 2 plus 8 plus 8 plus 1. That's 19. So what's the question ask? How many neutrons? Well, all they wanted you to do was to take this minus this. You get 21. They didn't ask you to draw the picture. See ya.